3D finite element modeling. An introduction. I want to model a beam under flexion with a 1D elements. So I just make a line, can be on a sketch, and I make it in the direction X. I make it just 1000 millimeters long, and that's already all I want to model. That's a line, as you can see. And now I go over to pre and post, make my FEM, and here be careful to choose all geometry options. Okay, so here geometry option I've chosen to take over to finite elements everything, not only the solids. It's just a message about the point that didn't transfer, but that's not of interest. I just leave what I have here, nothing special. Once again this message, and here you have 1D mesh. Until now we made 3D tetrahedral mesh, we made swept mesh, that's the hexaedric mesh. Now I go to 1D mesh. In this course, in the fourth semester, I don't make the 2D mesh. That's something for class B in fifth semester. 1D mesh, a lot of different types. In the moment I'm using beams. That's the general 1D element. I want to mesh this line in, I don't take numbers. Normally I would say on this meter 10, 1 meter long thing, 10 different elements, but I say size. I'm leaving the size on 100 millimeters. Okay, you see in here we have a 1D collector with the mesh, but there is more or less nothing visible. The reason is we have not defined a section. Here you find 1D element section. You have to make a new section, and you have a lot of different section types predefined. You can also use face of solid and so on, but I just take this box, and in this box you see X, Z element, Z, Y direction. And you see also here it's this coordinate system, so I want something that's in the Z direction. Dimension 1 is in the Z direction, there I take 100. In the other direction I just take half, and there where is dimension 1, I just want a thickness, that's dimension 4. Oh, that's dimension 3, huh? Dimension 3 I want 10, and a dimension 4 I take, oh here I take 10, and here 5, so dimension 110 millimeters here. Okay, I can also preview this, take care of the coordinate system, not really good visible, yellow on this white ground. Okay, close, we don't see anything, so once again we have to change a little bit. On this mesh we can change the display. I want to see it like curves. Be careful, we defined 1D element section. We define the elements, but we have to connect it to it's in the physical properties. There you find the property of the beam elements. I say these beam elements are made constant with our box that's rectangular type, and I just choose the steel for that. So I defined that the property of this mesh is made from this box type element with steel. Okay, and you see now it's visible. So here with this edit display, right click on your mouse, you can change the visibility in this style. I just leave it like that. It's a little bit easier to fix it in the sim area. I put a load from 1000 Newton in direction -z, and on the end of this neutral line of the beam, just take the node, the last thing. So it's a concentrated force on the node, and also I make a completely fixed constraint on the other side, but also on the node. Don't take the mesh or the whole line. Okay, I made up the definition. I go on and look at the results. In the results I see the deformation. I can animate it, and you see the deformation, and you can look at the stress. It's a little bit strange here with the stress. We don't see what we like to see on a beam with flexion or a channel beam. We don't see torsion, etc. So I go back, and in solve I can here in the edit solution attributes change in the case control area, case control. I can change the output request. With the output request, here I'm looking for force. So you have different sources, but here force, I enable the force request. Okay, okay, I let it analyze once more again. I'm looking at the results, and I got some interesting new results down here. You have the actual force, that's no. You have the bending moment, and you see here a lot of 1 million Newton millimeters. In the moment it's Newton millimeters. You have no bending moment in also direction. You have no torsional moment. You have no force in the direction y, but you have a lateral force in the direction z. And now if you change to stress, it's an interesting feature in here. You find here this icon beam cross section view. You click there where the element is. I take an example, this point, and preview shows you what's happening with the stress. A large stress top and down. Don't mix up the direction. That's Z direction, that's in the height. So that's neutral axis. There is it's just more or less nothing, and in the extremes you have here about a little bit less than 20 megapascals. I just leave that and I go to the X stress and cancel the X stress, and here in the X stress I say also I want to see that on this element as a preview, and you see it's a negative stress down here and a positive stress up there, like you learned it in the lesson of flexion, introduction to flexion. That's all. Try your first 1D calculation with the same elements from the scratch with a line dividing in 10 different elements like you see it here, and make later on that, compare the result with calculation you made manually, also analytic calculation. So that's all for the introduction to 1D elements.